Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the development of the lateral surfaces of the solids using the Solid Edge software. In this problem statement, we have a pentagonal pyramid of 30 mm sides of base and 50 mm axis length, resting vertically with one of its base edges being parallel to the VP and is nearer to it. It is cut by a plane passing through the extreme right corner of the base of the pyramid and is inclined at 30 degrees to the HP and being perpendicular to the VP. So we need to draw the development of the upper portion of the pyramid. So now the bottom half is chopped off and the upper half is retained, and we need to show the development of the upper portion of the pyramid. So now let us consider constructing the solution for this problem statement by drawing a xy line of thickness 0.18 mm. Now let us select a line of thickness 0.13 and then draw the top view of the pentagonal pyramid. So the edge length is 30 mm. The first angle is 0, followed by the edge length of 30 mm, and next the angle being 72 degrees, and next is 30 mm. The angle is 72 into 2, followed by 30, 72 into 3, and next the edge length is 30 mm and the angle is 72 into 4. So this completes the pentagon. But he states that one of the edges is being parallel to the VP. So now you can just see that none of the edges are parallel to the VP. So to make one of the edges parallel to the VP, consider selecting the pentagon, go to the midpoint and select this from the IntelliSketch. Next, go for rotate option, select the corner, and then the next point of rotation as the midpoint of the opposite edge to the corner that has been selected. So now rotate this in such a way that this line is exactly 180 degrees like this, so that this edge becomes parallel to the VP. So now select any one corner and place it in the same condition. So you can see that this edge is now parallel to the VP. So now let us consider completing the triangular faces. So from all the five corners, join the line to the midpoint of the opposite edge. So later on, we can use the trim option and trim the center lines of all the triangular faces. And this completes the top view of the pentagonal pyramid. So now let us draw the projection lines from each of the corners, intersect that with the XY line. In order to complete the front view, we need to draw the axis of the pyramid, which is equal to 50 mm, and the angle being 90 degrees. So this is the axis of the pyramid. So now select a continuous line of thickness 0.13 and join it to the end points of the projection lines drawn from the top view. So this completes the front view of the pentagonal pyramid. So let us keep the midpoint off in order to avoid the confusions. So now go for the smart dimension. Show the axis length, which is equal to 50 mm, and the edge length of any one edges, which is equal to 30 mm. So now let us consider annotating this. So first let us begin by annotating the XY line. So this is X and this is Y, followed by the reference planes, that is VP and HP. So now we'll start considering labeling from this corner. So let us tell that this is corner A, followed by corner B, corner C, corner D, and then corner E. O be the apex of the pyramid or the vertex of the pyramid, and O1 be the center of the base of the pyramid. So in the front view, this is O dash and this is O1 dash, whereas this is C dash and this could be D dash. Well, this is the corner E dash and then this is the corner A dash. So if you just see it, so this is the top view, and when you are seeing this particular pyramid from the vertical plane direction, so its front view will be generated like this, and this slant edges can be made hidden. So just select these two lines and then make it a dotted line, so which indicates that these two edges are behind and they're not visible in the front view. So now with this part, now let us go for considering the construction of the cutting plane. So the cutting plane is very clearly stated in the problem statement. It is passing through the extreme right corner of the base of the pyramid and is inclined at an angle of 30 degrees to the HP and is perpendicular to the VP. So select the line of thickness 0.13 mm, select the cutting plane. So the extreme right corner here is the corner C, and then you can just see that the angle is being taken in this direction. So if this has to be 30, this has to be 180 minus 30, so this will be 150 degrees. So just consider cutting the pyramid. Use the trim option to trim the excess line. So this portion is the lower portion of the pyramid, which is not considered for showing the development, but we need to show the development of the upper portion of the pyramid. So now we shall highlight the upper portion of the pyramid whose development shall be illustrated. So for that, from the corner C to the apex O, trace the path, and similarly the point of intersection of these slant edges to the apex. So you can just zoom in and then select the point of intersection perfectly. And also this part, I can just darken this, indicating that this is the portion of the prism. So now we shall annotate the points. So we'll move in a synchronous order. So from now, O dash to A dash is the first point, that is A dash. So it is interacted at the point 1 dash here, and the point is 1 in the top view. Similarly, the next corner is O dash and B dash. So we have got B dash here along the axis line. So this is the point 2. So this is 2 dash. So you can just go for the line option and you can just tell that this portion of the pyramid is also one of the slant edges. So let me select a line of thickness 0.13. So the axis line will be overlapped by this edge line. So this is 2 dash. And next we'll go for the next triangular edge, which is O dash and C dash. And that is the point 3 dash, which is exactly on the corner C. So we have got the point 2 here in the top view, point 3 here in the top view. So the next slant edge is O dash D dash. So this is point 4 dash, and next we have got 5 dash on O dash E dash. So this is 5 dash. So whereas this is point 4 and then this is point 5. So let us highlight the portion of the pyramid which is retained even in the top view. So go for the line option, select a line of thickness 0.50. So 1, 2, 3, 4, 5, and back to 1. So highlight all the triangular faces. So the next step is to draw the development of the upper portion of the pyramid. But however, the checkpoint here is to identify if one of the slant edges is parallel to the VP. So none of the slant edges, neither OB or OC or OD, OE, OA, so neither of these slant edges are parallel to the vertical plane. So what I'll be doing is, let me construct one of the slant edges parallel to the vertical plane. So for that, from the apex, I'll draw a line parallel to the vertical plane. I'll go for the arc by center point and measure the nearest slant edge to this horizontal line. So that is OC. And then I'll cut an arc of this particular radii, that is OC. And from this point of intersection of the arc with a parallel line, I'll drop a perpendicular upwards and then get the true slant edge by joining the endpoint to the apex. So this is the true slant edge. So what is the next step? Transfer all the points to this true slant edge. So this is 1 dash, and then this is 2 dash, this is 3 dash, 4 dash. So ensure all the lines are parallel to the VP and then intersect this. So we can just do the annotation of the points here also. So this is 1 dash followed by 2 dash, which is here. So 3 dash is anyways shown here. This is 4 dash and this is 5 dash. So these are the points that is to be used for marking the points on the development. So go for the smart dimension and show the measurement of this particular true slant edge, which is equal to 56.14 mm. And also go for the angle between. So the angle between this cutting plane and the HP is 30 degrees as given in the problem statement. So now we shall go for constructing the arc. So select the arc by center point and then let us sweep an arc of radii 56.14, which is nothing but the true slant edge. Correct? So just complete this by drawing a line from extreme point to the center of the curve. From here, divide this into 5 equal parts. So each part will be measuring 30 mm because it is a pentagon of 30 sides. So the arc length here is 30 So just cut an arc. Then from the point of intersection of the arc and the main arc again 30 sweep an arc. From the point of intersection, sweep an arc of radii 30 again. So repeat the steps till the entire arc is divided into 5 equal parts. Use the extend to next option and extend this arc here. Now go for the line option and then join it to the point of intersections. And then join the base of the pyramids. So all the base edges. Join it to the end point. Go for the trim option and then just trim this arc that was used for construction purpose. So this is the initial cut section of the entire pentagonal pyramid. But in this cut section, we need to show only the upper part of the pyramid that is retained after the cutting plane has chopped off this pyramid in this particular fashion. So now let us go for annotating this. So we'll begin from the apex of the pyramid, which is capital O, followed by the corners of the base, that is A, B, C, D, E, and then back to the slant edge OA. Correct? So these are the 5 points. So now we need to show the arc radii, which is equal to 56.14, and then show the dimension of any one base edge, which is equal to 30 So now we shall mark the salient points. So go for distance between. So on OA, I've got the point 1. So O dash to 1 dash, which is equal to 31.56. So here I'll go for the line option. From O, I'll draw a line of length 31.56 on this and as well as this slant edge 31.56. So I've got the points 1 on OA. So next I'll go for the distance between and measure the distance between 1 and 2, which is equal to 40.4. So go for the line option. OB, draw a line of length 40.4. And next we have got O dash to 3 dash, which is on OC. So go for O dash to C dash. So it is exactly on the base corner. So this is the point 3. Now we'll go for the next point, that is O dash to D dash. So on O dash to D dash, it is the point 4. So the point 4 is here, which is equal to 48.87. So go for the line option and then measure or draw a line of length 48.87. Next, we need to look at the point 5. So go for distance between O dash to phi dash is equal to 34.44. So on O dash D dash, draw a line of length 34.44. So now select a line of thickness 0.50. So from the apex, join it to the uh, endpoints of the lines that we have constructed. This is C, then this point. So first let us complete drawing the line of length 34.44, and then join the upper part of the slant edge to show the development. So now let us label the points. So this is point 1, 2, 3, 4. So here O2 4 is 48.7. This is okay. So the points have been swapped here. So that is OD and OE. So O4 is on O and D. So let us just rectify this. So enter the length of the line as O2 4, which is equal to 40.4. So now this is the new point. So go for 3, 4. So we can just cross verify 31.56, 40.4, and then this will be equal to the exact true slant edge. O24 is 40.4. Okay, O24 is 48.87. So still this is a mistake here. So select this line 48.87. So this is the point 4. So on OE it is the point 5, which is equal to 34.44, and this is equal to 31.56. Okay, so now the points are correct. So with this we complete the development of the prism in the given condition. Point 1. So go for the annotation and then write development inside the actual cut section of the pentagonal pyramid. So this is the development. So with this, we complete constructing the development for the given problem statement, wherein we had a pentagonal pyramid in such a way that it was resting with one of its edges being parallel to the VP, and then it is having a height of 50 mm, and each of the base edge measures 30 mm, and then it is interacted by a cutting plane which is passing through the extreme right corner of the pyramid and is making an angle of inclination of 30 degrees with respect to the HP and is perpendicular to the VP. So with this, we complete the development for the given problem statement. Thank you all for watching.